Hi, my name is Dr. Matthew Michael. I teach at NJIT. These are going to be my videos on Calc 3. Hope these are helpful. So we start off talking about Calc 3, talking about the differences between Calc 1 and 2 and Calc 3. I.e. in Calc 1 and 2, we're talking more specifically about what does it mean to, in Calc 1 and 2, we're talking about how to do calculus in technically two dimensions, but using one variable. How do I differentiate with respect to x or to t, depending on, but most specifically with x. But now, in Calc 3, we're going to need to expand our scope, allow for more variables. Most of the time, we're only going to be able to, well, not be able to, but we're mostly only going to talk about 3. It's three-dimensional. But these same concepts will work in dimension. So if you see other Calc 3 textbooks, you might see more technical jargon, but a lot of the times you can simplify and just add a little bit more. An extra variable or two, and the same concept still holds, which is why we are going to stay with a three-dimensional case. So in this case, our z dimension, our depth, will be dependent on x and y. So let's talk about three-dimensional systems. This section is mostly about definitions and raising the dimension of our already known stuff. So like I said before, we've only really dealt in two-dimensional space, or one variable, either with x or with y. And so we're going into three-dimensional space for the first real time, even though you kind of got hinted at maybe a little bit with polar. And so we've dealt with solids of revolution, but now we're mathematically entering a new frontier. Even though technically you've lived there, we're not going to talk about it mathematically. So, three-dimensional Cartesian coordinates means x, y, and z, not just x and y. And we're going to base these off of three axes, because we have three different coordinates, x, y, and z axes. And it's going to be very much like the right-hand rule, if you remember back. So you take your right hand from the x-axis. You can curl the fingers from your right hand into the y-axis if you move it 90 degrees, and your thumb will point in the z-axis. So we're going to have three different coordinate planes. So before we only had the xy plane, but since we now have three axes, we have three choices of planes: xy, xz, yz. And so we talked about this in class, but if we only represent, say, x is equal to 2, instead of it being a vertical line, now it's a whole plane. More specifically, it's going to represent the distance to the yz plane. So it'll be a yz plane, but off by a certain amount. Similarly, the y-coordinate represents how far off you are from the xz plane, and z represents the distance to the xy plane. So here is our right-hand rule kind of approach. We're going to divide them. Instead of, we had two axes before, so you divide each axis divides space into two parts. So two axes times 2 each time becomes 4, so we call them quadrants. If we had one more axis, we now have another 2. 2 times 2 times 2, guess what? We have 8, or 8 octants. We're going to like spending time in that first octant. I don't know if it's actually called that, but in the positive octant as much as possible, because we like it there. We like being positive. Here's the different planes, as we've mentioned before. The xy, xz, yz. So I kind of envision that your computer screen is your xy plane. And so but in reality, when you pull back out from looking at it, you add those extra two planes. So almost like a movie coming out of the screen. So we talked that z equals 3 means it's off from the xy plane by 3 units. So if we take a look at an equation like x squared plus y squared is equal to 4 and z is equal to 3, we know what x squared plus y squared is equal to 4 is. That's a circle with radius, that says 4, but radius 2. Z equals 3 means that's saying it's 3 units off. So instead we have the circle with radius 2, 3 units steps away from the xy plane. In 2 dimensions, we have the distance formula with 2 parts. Well, 3 dimensions means 3 parts. I know, mind blown, right? So, circles, x squared plus y squared is equal to r squared. Well, sphere is just a 3-dimensional version of that same circle, if you will. So we just add a third part. Notice the distance formula kind of is the same thing as our answer for circles or spheres, respectively. But more frequently, you might see the more general case. So we tend to call this the standard formulas for circles and spheres. But we will more frequently, when we actually get this in a real-world scenario, we'll frequently get this in terms of a general equation. So we need, in order to put this into a standard form, in order to get the center and radius. So we complete the square. Group by x's and z's, since y is already done. Move the negative one to the other side. Complete the square. And we see that we get a radius of square root of 21 over 2 and a center at negative 3 halves, 0, 2. Hope this is helpful. Please leave a comment below if this is if you have any questions, and I will hope to answer.